So we're just going to take notes on a whole bunch of different proofs. Hardest thing about today is determining what theorem to use. So looking at problem number 1, what do you think we should start with?
Givens.
Writing down the givens. Okay, do that. You know that I personally like to write the givens on different lines, so I'm going to do that. Okay, so we know that angles 1 and 2 are congruent. Do those give us anything? Does that give us an A? That's what I'm asking. Yes. The only question is, are those angles of the two triangles? Yeah, so they give us an A. I know angle A is congruent to angle E. So angle A is congruent to angle E. Use a different marking. So that gives us another A. And then we have C is the midpoint of AE. Does that give us an S? Guys?
Yes.
No.
Are there any sides marked congruent?
No.
No, that doesn't give us an S then. But it does tell us something. What do we know because C is the midpoint? Lucas?
AC is congruent to CE.
Okay, if C is the midpoint, it creates two congruent segments. So we get AC is congruent to CE. Okay, and then what is the reason?
Definition of midpoint.
Definition of midpoint. Okay, and let's mark that. AC is congruent to CE. Now that gives us an S. Okay, so right now we have two A's and an S. Can I just read down the side and say that the triangles are congruent by AAS?
No.
No. Okay. Two A's and an S. There are two theorems like that. What are they?
ASA.
So it could be ASA or
Yes.
AAS. So we got to figure out which of those two theorems is it. The first theorem means I have the included side. Second theorem means I have a side and it's not included. Looking at our figure, is that the included side? So is it the side in between the two angles?
Yes.
Yes. So that would be ASA. So we now can say triangle ABC is congruent to triangle EDC by ASA. Questions? No? Okay, proof 2 I think is particularly easy, so we're going to skip that one. So go to problem 3. The problem 3 is this. Okay, so we have quadrilateral PRST. Do we know anything about quadrilaterals?
4 sides.
Means that it's 4 sides. Is there anything else that's special about it? It's lateral? What does that mean? To be lateral. What's quad mean?
4.
So quadrilateral means 4 sides. But besides the fact that there's 4 sides, anything else that's special? So that is pretty much useless information. That just tells you that you have to figure which 4 sides. Nothing special about it. But it does tell us that PR is congruent to ST. Okay, PR and ST. Oh, that's a given. Does that give us anything? An A, an S, an H, an L, anything like that? Gives us an S. It's a pair of sides. Okay, and then we also know that angle PRT is congruent to angle STR. Okay, I want to make sure that we know how to label those angles correctly. Megan, can you tell me which angle is PRT? Tell me where to move. So, like, move to the left to get to the angle. Move up.
Left.
That one? Lauren, you agree?
No.
Okay. Where would you move?
Go up. Yeah.
Okay, good. P, R, T. And then R has to be the vertex, so it's that angle right there. Sani, can you tell me where angle STR is?
No, what's that now?
Go which way?
I don't get what you mean by the question. Like,
Tell me which angle on the figure is angle STR.
on the R, you put a,
Up there?
yeah.
No. Yuritsa?
The T.
This side or that side?
That side.
So the right side?
Yeah.
Okay, that one. STR. So I go S, and then T, and then R. T is the middle one, so that has to be the vertex. Okay, that gives us an A. There's no theorem SA, so there has to be some other piece of information that is true about the figure that we do not know. Toby, anything else that's true about the figure that is not marked?
RT is congruent to itself.
Okay, so we get RT. It's congruent to RT. Andrew, what's the reason?
Reflexive property.
Reflexive property. Okay, so that's that side right there. So that's an S. If we have two S's and an A, our only option for a theorem is SAS. Now, we can't just say, okay, great, SAS. You gotta look at the figure and make sure that it's in the correct order. Lauren, does this figure show SAS?
Yeah.
Yes, it does. We have two sides, and we have the included angle, the angle in between the two sides. So now we can say triangle PRT is congruent to triangle STR by SAS. Questions? No? Okay. We're going to look at the next one, and then I'll let you guys do one together after we do problem 4. Problem 4. We have quadrilateral PQRS, which I already told you that is useless information that does not help us at all. But we are told that PQ is perpendicular to QR, and that PS is perpendicular to SR. And we know that QR is congruent to SR. These are both givens. Okay, so QR is congruent to SR. That's there. What does statement 1 give us? Like, why, what are we supposed to gather from that? Phil,
Angles,
what about the angles?
like perpendicular angles that points to S and Q.
So perpendicular sides create what? What does it mean to be perpendicular? Forms right angles. So PQ is perpendicular to QR. PQ and QR, so this is a right angle. PS and SR, so that is a right angle. So that's the next thing that you need to say. Angles Q and angle S are right. Why is that true? So what is my reason for that? Jake?
Definition of perpendicular.
Very good. Definition of perpendicular. Okay. Anytime that you have right angles, the hardest thing is determining, is this HL or not? So before we go any further, we have two right angles. We need to determine, is this going to be an HL proof? Well, either way, we only have one pair of sides that are congruent. So we need another pair before we can determine anything. Are there any other sides that are congruent? Or any angles? Anything else that's congruent that's not marked? Alex.
PR is congruent to PR.
Okay, so we get PR is congruent to PR. Alex, reason?
Reflexive property.
reflexive property. Okay, so PR is congruent to PR. Okay. Based on this figure, is this an HL proof or is it something else? What does the H stand for?
Hypotenuse.
Hypotenuse. Are my hypotenuses congruent? Hypotenuse is the side across from the right angle. So across from the right angle, this is a hypotenuse. And then do I have another pair of sides that are congruent? Yes. So this pair of sides, that's not the hypotenuse, that's the leg. So that's our leg. This right here is our hypotenuse. So we have H right here. We have L right here. Are we done then? Great, this is HL. HL is that weird proof where you have to show what?
Work.
Did you just say work?
Yeah.
Don't you have to show work for every other type of proof?
Yeah.
Okay, so no. With HL, what do you have to prove before you use HL? Alex, do you remember?
Hypotenuses, right?
No, but thank you. Lucas?
Triangles, right?
Remember how HL only applies to right triangles? So before you use it, the triangles have to be right. Have we said anywhere that we have right triangles?
Yes. Q also right?
Have I said a triangle blah 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 is right?
No.
No. So that's what we have to say for statement 5. Triangles PQR and PSR are right. Why are those right triangles? What makes a right triangle? Like, what is the definition of a right triangle?
90 degrees.
Has a right angle. Okay, we've already said that we have right angles. So now all you need to say is all right triangles have right angles. Which is certainly true here. We said right angles. Okay, we have right triangles, got that. We have our H, we have our L. So now we can say triangle PQR is congruent to triangle PSR by HL. Okay, that's like the 3rd or 4th proof of that type that we have done together. So you guys need to remember that, please. I know that HL is a tough one, but you should be able to do it. Questions before we move on? Flip the page then. Okay, right now I would like you to do problem 5 with your group. So move your desks together and start working on problem 5. Please call me over when you are done.
Alright. So we're given P by 7 and L.
Lucas, you can help. Don't give answers.
Did you do it on the calling?
Okay. What's the bicep? 2 sides. So Alright, good talk.
Just staple it in your notepad. Oh, right. I don't really know either way, whatever you prefer. Oh, you're done.
Yeah.
That's right. This, you need a name by because then you talk about angles P and angles Q. Those angles are true, not for that reason.
So M and T and elements.
Wait, is that just
Yeah, so bisect is LP and PS.
So not positive reinforcement whatsoever.
Semi-positive.
No.
That's what you mean.
Okay, when you are finished, let me check and I'll let you move on to 6th one.
MT and LS are both interior.
This is where we use this.
So I can just leave it?
Sure.
So I don't have to write both on.
No.
I write both on the same line.
I was right.
So you have parallel angle.
Yeah.
You need something, you need another something, this is the mistake at 6.
Well, if you did SP, then SP equals this.
Oh, it is S.
Okay, look up here, please. I want to start going over this. Majority of you made a mistake somewhere along the way. Okay, so we have P bisects LS and ML. What's that symbol?
Parallel.
Parallel. Parallel.
Same parallel.
Hey, can we quiet down, please? Okay, at this point, do we have any A's or S's?
No.
Do we have any angles congruent or any sides congruent?
No.
No. If two sides are parallel, does that mean that they're congruent? No. Okay, P bisects. What was that supposed to give us? Michael?
Vertical angle.
No.
What is vertical angle?
That's true, but that has nothing to do with the bisector. Toby?
Two equal sides.
Hey. Two congruent sides. And what sides are those?
LP and PS.
Okay, so you should have gotten LP is congruent to PS. If I bisect a segment, so LS is a segment, I end up with two congruent segments. So then this should have been definition of bisect. So those two are congruent. That gives us an S. Okay, now like Michael said, we also have vertical angles. Okay, Michael, can you tell me what those vertical angles are?
Angle MPL and angle SPT.
So angle MPL is congruent to angle SPT. Please make sure, first of all, that you put angle symbols. Second of all, that you write by 3 vertices. If you only write angle P, I don't know what angle you're talking about. So those are vertical angles. So that's here. So that gives us an A. Okay, so far we've used the bisect statement. We haven't used the parallel lines at all. So what were we supposed to gather from the parallel lines? So,
That angle L is congruent to angle S.
okay, so angle L is congruent to angle S. If you look for the Z, so that angle is congruent to that one. That's an A. Phil, how do I write the reason?
If parallel, alternate interior angles are congruent.
So if parallel, I said parallel already in statement 2, then the alternate interior angles are congruent. Okay, now I have triangle LMP is congruent to triangle STP. With 2 A's and an S, my options are either ASA or AAS. Why are you guys talking? Wonderful. I bet you were just going to tell me which theorem it was and why.
AAS.
No.
It's ASA because
Well, yeah, there's only 2 options and you guessed the wrong one, so
it's the
of course
angle
it has to be the other one.
it's the side between the 2 angles.
Okay, that's the included side. I have 2 angles and the side in between. So this is ASA.
Wait, but I put MT as alternate interior.
Okay, that's AAS then. That's not the
Yes.
proof we did though.
Okay. Well, it was still right though, for mine.
For your proof, yes. Not for my
That's what
proof though.
matters.
No. It's not what matters.
As long as
You know what matters? Respect.
That's actually true. I wouldn't do.
Thank you. Someone gets it.
Okay. Your exit slip, so you are able to leave this class if you can do 6 correctly and show me. Now, if you finish at 11:08, that doesn't mean that you get to leave at 11:08. But you have to stay until that one is finished.
You might be here for a
When you
while.
are done, come up and show me.
Can you scroll down?
You have a pet. Oh no, you don't.